Okay, so this is going to be our second lecture on introduction. Probably two more or three more lectures we will be having on introduction, and then we'll move to the more technical parts. So, just wanted to give you how power system evolution has happened. So, just wanted to give you a quick history from where we have started and where we have reached till now. So, just wanted to give you a heads up for that. So basically, the first commercial use of electricity started in 1870s, which was mostly on street lighting. So that was the major focus in 1870s, and then the most one of the most popular electrical scientist, which was Thomas Edison. He developed a full power system in 1882 in New York, and this was totally based on DC system. I'm actually having a pen, but it is not working, so I don't know. Probably I'll fix it out. So so DC system is it was a DC system in what Thomas Edison has developed in 1882, and it was running a DC generator, having few customers, and it was in a very small radius. It was spread, so radius of 1.5 kilometers, and most of the loads were just the lighting load, nothing else, because there was no other development till then. So in 1884, the another scientist named as Frank Sprague, he developed DC motor, and after the development of DC motor, lot of appliances was started developing, because in if you see in our today's daily day-to-day life, almost every appliance uses a motor, not necessarily a DC motor, but yes, they use motor. So even if you see your air conditioner, refrigerator, fans, everywhere you will see a motor is there. So that's why DC motor was a big invention, and because of which this was the start of development of a biggest industry. So if you see today, the biggest industry in the world is electricity industry, because you can see the amount or the scale of the industry. You can also see the money involved into it. You can also see the infrastructure. It's huge. For any country you take, the electrical industry is the biggest industry in most of the especially in India, US, Europe, everywhere it is the biggest industry. So this was the start, how people started looking at electrical systems. Then we moved towards rise of AC systems. Why? Because DC has some limitations, and people started observing those limitations by 1886. And those limitations were, you cannot deliver power to a longer distances, because I square R losses were there. So if you try to dispatch power for longer distances, then due to the network losses, the power received at the receiving end used to be very less, and which does not allow all the appliances to work. So therefore, it doesn't make sense for allowing DC system to travel more. And also, to compensate that, people thought that, okay, let us generate at a higher voltage. And if you generate at a higher voltage, then you do not have, because those days there was no converter or anything of that sort was there. So people, there was no appliance who used to work at higher voltages, and it has a negative impact on appliances also, that it can get damaged. So it requires voltage transformation. So that was the yeah, sorry, I'm not okay today. Yeah. So then after that, another scientist, they developed AC transmission systems, and this was a big transformation where people saw a lot of advantages. For example, as soon as you have developed AC transmission system as well as transformers, now we were able to see a lot of advantages in AC systems. And you can see here that there was a person called George Westinghouse. He was actually a businessman. He actually invested money on developing this AC transformers and transmission system. And he brought, actually, because it was actually developed in France, but he brought every technology to US during that time. And then he tested a first AC transmission system in US in 1889, and which was just a single phase line. So obviously, if you have a single phase line, there were some cons on that also, because you cannot transfer more power if you have a single phase line. So then the next popular scientist which everyone knows is Nikola Tesla. He developed a polyphase AC systems, and which has lot of advantages. He proposed an idea in 1888 to develop AC motors, generators, transformers, and transmission lines, and the complete system. And he had all the patents for that. But because Nikola Tesla was actually an employee or working in the company of Westinghouse, so eventually Westinghouse purchased or bought all the patents. And basically Westinghouse, till today, Westinghouse owns all the patents of the current AC system. So whatever product you purchase which has AC systems involved into it, a small, very small portion of it goes as a royalty to the Westinghouse till date, because it has all the patents. So whenever, I'm sure you all know about the concept of patents, where you file a patent, and if someone wants to use your technology, then they have to pay the royalty to for using those equipments. Now, obviously, you saw there was one scientist called Thomas Edison, what we saw in the first slide. He was proposing DC systems across the world. And there was another in businessman, I would say, was Westinghouse, who was promoting AC systems. Now, it was a big controversy, but we knew that the DC systems had limitations. So there was a big debate happened in 1890s, and a lot of testing happened during the time. And then eventually people thought that, okay, no, AC is the perfect thing, because the main reason was there was no converter available, because those days there was no concept of inverter or converter. You cannot step up or step down a DC voltage, and which you can do easily in AC systems. So that was the biggest advantage in those days. Also DC, because it requires the maintenance is higher for DC machines, and also the design is complex. Also, you need a commutator. I'm sure if you have seen the DC motor or generator design, there is a commutator which actually converts the AC into DC, and that creates a friction, and it gets over the time it needs replacement. So that's why the maintenance was higher, as well as the cost of developing a DC machine was higher compared to AC systems or AC machines. machines. So therefore AC has almost won the battle in this. And then the complete time after that, whatever development happened was always focused on AC systems. But the another problem in AC system was what should be the frequency of the AC system. So I'm sure everybody knows that how we arrived at 60 hertz and 50 hertz. So basically, people tried a lot of different frequencies: 25 hertz, 50 hertz, 60 hertz, 125 hertz, 133 hertz, and both type of frequencies has different uh, impact on the appliances. For example, if you have higher frequencies, then the size of the appliances, you can reduce it to a smaller level. But the problem happened is it gets heat up very fast. And if you have slower frequencies or smaller frequencies, you need a bigger systems, because it to if you imagine from the wavelength or that point of view, you need a bigger systems. The size of appliances becomes higher. So there was a trade-off. So eventually, North America, in most of the countries in Europe also, they went for 60 hertz, and in India and in most of the countries in Europe, people also went for 50 hertz. And it was there is no logical reason why they went for 60 and 50. It was just they were trying different frequencies, and they arrived at 60 hertz and 50 hertz. Right. So this was the logic, how they arrived at frequency, and they made it a standard. And then another issue arises, that what should be the voltage level for transmitting. So then for this also, in people tried different voltage levels. Initially, they started with a smaller voltage level, which is actually 12 44 60 kV RMS line to line. And then they because obviously they wanted to transmit power for longer distances, they went for higher voltages, which is 165, 220, 287, 330, 735 and 765. So this was the different voltages what people tried. And then eventually, because we have to arrive at a standard, so there was a standard voltage set across the world of 765 kV, 400 kV, 220 kV, 132, 110, and so on. So this is the idea how they arrive at a standard voltage, and they arrived at a standard frequency. And after that, once you have a voltage and a frequency set up with you, this AC system becomes very, very convenient for everyone. Even the industries which are manufacturing electrical appliances or electrical components, they got an idea, okay, what in which domain they want to work on, in which voltage level they want to work on. So they can design their appliances or machines or equipments in a more convenient manner, because these uncertainty is resolved now. Okay, so this was the controversy between AC and DC system. Now coming back to the Indian power system, how Indian power system evolved across the time. So I'm just dividing the complete development happened on Indian power system between pre-independence era and the post-independence era. So in the pre-independence era, there was just to give you a quick update, that in the first electric light in India was demonstrated in Calcutta. Though that time it was Calcutta, but now the name has changed. So it is done in 1879, and thereafter, because India was under British rule, and in those time there was first Electricity Act, which came in 1887, which was just to protect and protect people from the risk of electrical shock and injury, because obviously electricity can be dangerous. So that was came in 1887, and then after 10 years, 1897, first hydro power plant was developed in India in Darjeeling. It is the a city in the eastern part of India. And then the two more Electricity Act came, 1903 and 1910, where it was trying to regulate and encourage people at the local level, so that at the local level people can start producing and consuming electricity. But after 1910, not much of a development happened because of World War and all. There was no much development happened in India. But after the independence, we got independence in 1947. After that, the first Electricity Act came in 1948 after the independence, and which was on the development of state electricity boards. So all these states were given the responsibility that okay, you start your own production, basically your own generation, your own transmission, and your own means you satisfy your own consumers. So all state was having the responsibility to do that. And in 1964, after a bit of a gap, they come so they gave some time for all these states to develop their infrastructure. And in 1964, they developed regional electricity boards. So right now India is divided into five regions: east, west, north, south, and one is northeast. So there are five regions, and all these five regions. So basically, what they did, initially all states were there, and then they connected all these states to five regions. So different regions, all these states within the northern part of India is connected to the northern region. And in after that, people saw that the development or the electricity usage was more into the city areas but not in the rural areas. So in 1969, to encourage the rural electrification, they came up with the new rule that okay, a growth should be there, electricity infrastructure growth should be there in the rural areas as well. Later on in 1975, one of the most, I'm sure all the students from India, they know that NTPC, National Thermal Power Corporation, NHPC, National Hydropower Corporation, NIPCO is also another company in the northeast. So they actually means basically Indian government decided to develop central generating companies, or that is controlled by these not controlled by the individual state but controlled by a central entity. So these different power plant, because load started increasing and we do not have enough generation, so therefore in 1975 they come up with new rule to develop power plants on the by the central government. But again, in 1986, the problem what we faced is we need money for the development of these power plants. But initially, money was always invested by the government, but it was still lacking in some sense. So in 1986, government initiated Power Finance Corporation. So basically, this institution, the role of this institution was to create funding for the power sector. So power sector means either generation, transmission, distribution, all these sectors, whatever, if they want money to develop their infrastructure, they can approach Power Finance Corporation and they can get money from there. So that was another advantage what happened in 1986 using via this PFC. And then in 1989, Power Grid Corporation of India was established. Basically, Power Grid, initially it was a part of a central agency only, because all this NTPC, NHPC were connected directly to the central grid. And then that central grid was actually carved out of the complete asset, and they made a different entity that, okay, Power Grid Corporation will only take care of the transmission infrastructure. So obviously, as the system was increasing, the size of the system was increasing, we need different leaders, or leadership roles has to be divided so that different people can take care of different activities, obviously in hand. Tomorrow there will be lecture, not today. Okay, so tomorrow we'll meet. Not today. I'll tell you when we are starting the tutorial. So not today.